Hi everybody, in this video we will learn to create this kind of liquid shader effect, and we'll see that how we can control this shader effect according to the player movement in the gameplay. To achieve this effect, we are not going to do any full liquid simulation, but we will just fake this kind of liquid movement. Mostly this effect is for stylized games and also for lower end devices like mobile games. So as usual, we start with a 3D model that I downloaded from Sketchfab. I have given its link in the description, but the technique we'll use in this video doesn't rely on the 3D model. This technique can be applied to any type of 3D object. The important thing is that the liquid mesh in this example should be a separate mesh. So in this case, it is actually like this. This is our final 3D model. Let's start with a new shader. Let's name this liquid shader. Let's create a material from this and apply it on this liquid mesh. Right now, I'll hide this so that we can better understand the liquid mesh or the liquid shader. Before creating this effect, I believe that a basic understanding of this effect should be understood first, that what kind of logic or what kind of math is required to achieve this effect. The first thing is that we have to show a fill amount for this liquid, for which we will need a variable which will show us how much liquid is filled or how much is empty. So as a start, we require a mask like this from bottom to top, on which we will able to show its fill amount by applying a step value or applying a step node. To create that kind of mask, the first node we require is the position node, so that we can create such a mask by using the Y component of the position node. So let's start with the position node. Set this position node to object space. Let's split this and use the Y component in the base color, which will create this kind of mask. Let's use this value in the step node. Let's create a variable for the edge value of the step node. Convert this to a property and use this output in alpha. We don't have alpha. To show the alpha, I go to the graph setting and turn on the alpha clipping. Use this output in alpha and let's remove this base color for now. The result is something like this, but we want it to be inverted. For that, let's reverse these inputs of the step node. Now the result is like this. Let's also show the back faces of this model. Go to the graph setting and set this render face to both. Right now it's giving us a result like this. The main problem we have right now is that if we rotate this object, then this cut is not always parallel to the ground, the way a realistic water or liquid should behave. This is showing us something like this, but we don't want that. We want this cut to be always parallel to the ground. To achieve this result, we cannot use a simple position node that is in the object space. Rather, we will use this position node in the word space and subtract the object's position from this, which is available to us in the object node. Let's subtract this and use this output in split. Now at this point, the cut we have is always parallel to the ground, whatever the rotation we keep of the object. As a whole, it will look like this. The liquid surface is always parallel to the ground. Now it is behaving somewhat like a liquid. The second thing we want to achieve is this kind of wobbling of the liquid surface, for which we'll have two parameters inside the shader, which we'll control from inside the shader at this moment. But later, we will control these two values through a script. A shader effect which is triggered within a gameplay is always achieved in the same way, that a 3D artist or a technical artist creates some parameters to change some of the values while creating the effect. Then at the end, gives the access to those parameters to a developer, who then takes those values and hooks them up to specific events or triggers happening inside the gameplay. For this example, we'll create such a wobbly effect inside the shader, and then with the script, we will control these wobbly parameters according to the movement of the object or the movement of the bottle. To create that kind of a wobble, we'll get back to our shader and we'll use a node called rotate about axis. What we want is to rotate this gradient, from which we are trying to rotate this cut. We want the cut to rotate on the x-axis as well as on the z-axis. We'll use the output of these nodes here. To rotate on the x-axis, we'll put the value 1 here and we'll duplicate this node and set its value 1 in the z-axis. By changing the rotation value, it will give us a result like this, which if we split and preview it, it will give us a result like this. In degrees, set the rotation of these nodes to 90. To simplify this further, we will multiply these by two variables. Change the name of this node to rotation X or rot X and change the name of this to rot Z. First add these rotation values together and then add these to our base value. And separate these values, which will be used as an edge value in the step node. This is the full graph so far, which will give us this kind of result with these two variables. Rot X to rotate on X-axis and rot Z to rotate on Z-axis. Remember, the liquid surface should always be parallel to the ground, the way a realistic liquid behaves, for which the value of these two variables should remain 0. We'll control this exact thing with a script so that these values change according to the movement of the player or according to the movement of this bottle and then stabilize and become 0. Before using the script, let's give some colors to this liquid surface. Let's change the surface type to unlit. Let's create a color node for the base color node. Set its default value to this one. This will show us an unlit color like this. Let's create one more color. Let's name this top color. Let's blend these two colors a little bit with the lerp node and its front face as a T value. The front faces of the 3D object are showing this color and the interior faces of this object are showing this yellow color. This is an unlit shader, that's why this yellow color looks like the surface of the liquid. Let's take another lerp node and use these two nodes here and use the Fresnel effect at this T value. Use this output here. Right now there is a slight yellow outline showing here, which we can further intensify by multiplying with the variable. It's giving us a result like this. Now to control these two values in the shader with this script, the first thing we need is to make the scope of these two variables global, so that we can control these two variables from any of the script in Unity or even from another shader in Unity. In this case, what we want is that the value of these two variables should be seen changing with the movement of the player or the movement of the bottle. So to change these variables globally, what we will do is change the scope of these two variables from per material to global. Now we can control the values of these two variables with any script. The main thing we'll need from this shader is this reference value. We will give these references to ChatGPT, which will create a script for us, which will change the values of these variables or these reference variables. Let's go to ChatGPT or Gemini and write this prompt. That will write a script for us that will change the values of these two variables underscore rot x and underscore rot z, which are the reference names of these two variables. We'll copy the script and use this inside Unity. All this script is doing is updating the values of these reference variables. Let's copy this code. Let's come back to Unity and create a script. We name the script the same as the name of this main class, and after deleting this code, we will paste that code inside it. Let's apply the script to the liquid object. This Gemini script also gives us some public variables that we can change, such as wobble speed, recovery speed, and maximum wobble. Let's go to play mode and let's try to move this portion, which is giving us a very fast effect. Here, let's keep the value of this wobble speed as 1. Let's move again. Now you can choose this value as per your wish. Now we can also further amplify this effect, where by moving it or rotating it, it appears to be a very flat liquid surface. We can also enhance this. We will create a sine wave from this liquid surface and multiply it with our wobble, so that when the wobble is increasing, it will create a sine wave. And when it reaches flat, then the sine wave also disappears. Let's get back to our shader, and from this surface level that we have finalized, we create a sine wave. Let's split this and use its x value in the sine node. To control this sine wave a little bit more, we can also add the frequency and amplitude parameters. So let's multiply this x value with the frequency variable. Let's create a parameter here called frequency. Let's also add a time node. And let's also multiply the output of the sine wave with a variable called amplitude. Name this frequency and let's name this one amplitude. When we add this sine wave to our main liquid surface, it will give us a sine wave like this, which is getting added on the top of the liquid surface. This is what we want to control with the wobble parameters that we created with the script. So we will multiply this amplitude variable with the rot x or rot z values that we are getting from the script. Let's add these two values and then multiply it with the amplitude. Now the sine wave that we will get will depend on the movement of this liquid. Here we can now change its frequency and also set the amplitude. You can set these parameters exactly as you want. I don't like this much frequency, so let's set this frequency to 2 and let's set this amplitude to 0.9 or 0.8. We can also control this wobble with the script if the wobble is too much. This was the main logic of this wobble effect. Now you can further refine it. Like for example, I can pass this rotation x and rotation z values from an absolute node so that instead of a sine wave, it gives us a wave like this. The difference between these two waves is very subtle. Of course, it depends upon your choice. Now finally, after setting some parameters, it can give us a final result like this. That's it for this video. I hope you liked the video. If you have any question, please let me know in the comments. In the next video, we will learn some more effects and some more exciting and technical stuff. Thank you for watching. See you in the next video.